In this video, we will do several practice problems involving the derivatives of log functions. So let's first recall some of our formulas. So remember the derivative of ln of x. That was 1 over x. And if we take the derivative of ln of some stuff, some more complicated stuff, we need the chain rule for this. And the chain rule will say, we'll take the derivative of the outside thing, the ln, which is usually 1 over x. But when we do the chain rule, we keep plugging the same inside thing in this case, the stuff. So instead of writing 1 over x, I'll have 1 over the stuff. But then we do the chain rule step, and we multiply this by the derivative of the inside thing, the derivative of the stuff. Okay, so that's the derivative of ln of stuff. It's 1 over the stuff times the derivative of the stuff. All right, so I'm going to box these. And now let's do some practice problems. So from worksheet 7, this is problem number 7, and I want to first have you try parts A, B, C, D, and E. And some of these will be very quick. So overall, I'm going to give you 4 minutes to try these. Pause it in 4, 3, 2, 1, pause it. Try these for 4 total minutes. All right, so hopefully you've done that. Hopefully paused it and tried these. Let's talk about them. So for A, well, this one's not bad. Y is equal to ln of x. That derivative, we already know the derivative of ln of x. We wrote it up here. It's just 1 over x. Okay, so that's our answer to A. Let's move on to B. So for B, we have y equals ln of x plus ln of 3. Okay, so to take this derivative, I first take the derivative ln of x, which we know is 1 over x. And then now we have to do plus the derivative of ln of 3. So be careful. It's not 1 over 3. And the reason for that is when we plug a number like 3 into the ln function, this is now just a constant. It's just a number. And the derivative of a constant is 0. Okay, so that just gives me 1 over x. So that is our derivative here. If we wanted to do it a slightly longer way and use the derivative of ln of stuff, we would have gotten that the derivative of ln of 3 is, well, 1 over the stuff, so 1 over 3, but then we got to do chain rule on this and multiply by the derivative of the 3, of the stuff inside. But the derivative of 3, that's definitely 0, that's a constant. And 0 times something is 0, and that would have given us 0. So if we had used the chain rule formula for the derivative ln of stuff, we would have gotten 0, but we would have needed to remember, oh, this is chain rule. This isn't ln of x, it's ln of some stuff. Okay, but regardless, I think the first way we did it was quicker. Okay, let's do part C. Y equals ln of 3x. So I'm going to do this in 2 ways. Method 1 is to notice we have ln of some stuff, so we can do chain rule. We do chain rule on this. And doing chain rule, we'll get our derivative equals 1 over the stuff, 1 over 3x. And then times the derivative of the stuff, so times the derivative of 3x. So y prime equals 1 over 3x times the derivative of 3x is 3, and the 3's cancel and I get 1 over x. So that's interesting. Even if I do ln of 3x, the derivative is the same as it was for ln of x. Okay, and we can show why with method 2. Method 2 is to notice, ln of 3x, we could simplify that with log rules first. Okay, so let's show what this looks like. So we can rewrite our function. Because I have 2 things multiplied inside of this log, we can use the log rule that splits this up as ln of one thing plus ln of another thing. Because when you add 2 logs that have the same base, in this case ln means base e, then you multiply the insides. So this is ln of 3 plus ln of x, because now when you combine them into 1, and you would multiply the 3 and the x to get our original function. Okay, so now if we do the derivative, well, ln of 3 is a constant. That derivative is 0, plus the derivative of ln of x is 1 over x. Okay, so we just get 1 over x. All right, so we get the same answer as method 1. But method 2 more clearly shows that our function was actually just it was ln of x plus a constant. So that's why the derivative of it was the same as the derivative of ln of x. All right, let's do part D. This time we have ln of x to the third. And with this as well, I'm going to do it in two ways. Method one, we will do chain rule because we have ln of some stuff. Okay, so chain rule will say when I do the derivative, we'll get 1 over the stuff times the derivative of the stuff. This time, let's just do it. That's 3x squared. And I can cancel some x squareds and get 3 over x. All right, let me do this one other way. Method 2, we can also use log rules on this. First, method 2 is going to be log rules first. Log rules first. Because on this, we can use a log rule that says, well, if I have power inside of a log, I can bring it to the front to get y equals 3 times ln of x. And now doing the derivative, the 3 is just going to multiply the derivative of ln of x, which is 1 over x. And multiplying these, we get 3 over x, which is the same. All right, awesome. Let's do part E now. Okay, so for E, we had y equals the quantity ln of x being cubed. Okay, so we have some stuff being cubed. That's going to be chain rule. So chain rule will say deal with the outside thing, the power, that 3 first. Bring that down, subtract 1 from it. Keep the inside thing the same, so keep plugging in ln of x. But then multiply by the derivative of the inside, which is 1 over x. And that's it. That's our derivative. Okay. All right, let's do another couple of practice problems, but we're going to amp up the difficulty now. All right, so next I want to have you try. This is a parallel problem to part F on the worksheet, and then this is a parallel problem to part G on the worksheet. And I want to give you 5 minutes collectively to try these two. So pause it in 4, 3, 2, 1. Pause it and try these for 5 total minutes. Alrighty, so hopefully you did that. Hopefully you paused them and tried them for about 5 minutes. Let's talk about them. All right, so for F, I have ln of some stuff. So I need chain rule. My derivative, the derivative of ln of stuff, when I do the derivative of the outside thing, of the ln is going to be 1 over, typically it's x, but when I do chain rule, I keep plugging in the same inside thing, which in this case, the inside thing is cotangent of x minus 4 over the 5th root of 2x to the 6th minus x. Okay, and then the chain rule says, okay, now multiply by the derivative of that stuff inside. So the derivative of cotangent is negative cosecant squared x. And for the derivative of this fractional thing, it's going to help to rewrite the root as a power. And in fact, if I bring, so the 5th root is a 1 over 5 power. And if I bring that to the numerator, we'll get 4 times 2x to the 6th minus x to the negative 1/5 power. And now I just do chain rule on this. I get to avoid quotient rule altogether. All right, so when I do chain rule, I deal with the outside thing, this negative 1/2 power. That's going to come down. And with this other negative, it's going to give me a plus. Give me a plus 4 over 5. Okay, I'm going to leave some space. Subtract 1 from the power to get negative 6 over 5. So keep the inside stuff the same, 2x to the 6th minus x. But then we do the chain rule step, and we multiply by the derivative of the inside, which is 12x to the 5 minus 1. Let's close this bracket, and that's our answer. So it's a long answer, but nonetheless, that is it. All right, let's talk about this parallel problem to G. Y is equal to cosecant cubed of 2x times ln of x. So for this, we have these two functions being multiplied. So we need product rule first. Product rule first. And product rule says, okay, when you do the derivative, you'll get your first function, cosecant cubed of 2x, times the derivative of the second, which is 1 over x. And then plus the second function, ln of x, times the derivative of the first. So for cosecant cubed, remember, that just means cosecant of 2x, that whole thing being cubed. So this is a chain rule situation, and the outside function is this cubed thing. So I'm going to deal with that first and chain rule says, okay, bring that power down. The new power is going to be a 2. Okay, so that's actually going to give me 3 cosecant squared of 2x. I'm going to go straight to this form. Okay, but then chain rule says, okay, now do the chain rule step. And I got to multiply by the derivative of cosecant of 2x. And that's another chain rule. Okay, so the derivative of the outside part of that, the cosecant. Remember, the derivative of cosecant is, it is negative cosecant cotangent. And because we're doing the chain rule on that, okay, this was just the derivative of the outside part, the cosecant part. And when we do that, we keep the same stuff plugged in, which is 2x. I keep 2x plugged into both of these. And now we do the chain rule step, and we multiply by the derivative of the 2x, which is 2. And now we close this bracket, and we close that big bracket. And that is our derivative. That is our derivative. Let's do one more practice problem in this video. All right, so we are on to part H. All right, so we have this big old square root and ln of some stuff inside. First, do a pause for 3 minutes to try it. 4, 3, 2, 1, 3-minute pause. All right, let's talk about it. All right, so big old square root, we can write that as a big old 1/2 power. And inside we have the ln of arctan of 3t plus e to the t to the 4th. All of that is inside the ln. So this is definitely going to be chain rule. Chain rule will say, deal with the outside thing, the 1/2 first. So the 1/2 comes down, and then I'm going to subtract 1 from the power. So the power is going to be negative 1/2. And I keep plugging the same inside stuff in. So ln of arctan of 3t plus e to the t to the 4th, all of that is inside the ln. Now I have to multiply by the derivative of the inside, the derivative of ln of this stuff, which itself is going to be chain rule. The derivative of ln of stuff is 1 over the stuff, so 1 over arctan of 3t plus et to the 4th. But then we multiply that by the derivative of the stuff inside ln. So the derivative of all of this. I'm going to put a big old parentheses for that. Okay, for the derivative of arctan of 3t, that's another chain rule. The outside function is arctan. I know the derivative of arctan is 1 over 1 plus t squared. Usually I'd write t squared. But in this case, it's chain rule, so I keep plugging the same inside thing in. So I would write 3t being squared, and then I do the chain rule step, and I multiply by the derivative of the inside. Derivative of 3t is 3. Okay, and then I move on to the derivative of e to the t to the 4. This is itself is going to be chain rule. I'll get e to that stuff, e to the t to the 4 times the derivative of the exponent, which is 4t cubed. All right, and that is my derivative right there. It's a very long derivative. I needed 2 lines to write this one.